Hello viewer and welcome to my first Physics 2212 lab experiment. Let's get right into it. To start off, the introduction to this experiment was to determine how much excess charge is on a piece of charged clear tape based on their interactions. Now I used 4 core formulas for this experiment as seen on the right. The bottom one is a bit blurry as you can tell, but that's because my camera is crap. Let's continue. For the point charge, I found 1.323, etc. to the e negative 8c, and for the line, I got 5.97294 e to the negative 4c. Now, these values will be further explained in the future. Initial instructions are as follows. For the procedure, we have 4 steps. First, create U-tape by pulling the end of the tape off of the base and on the other with speed. Secondly, create an electrical charge and hold it near the U-tape and observe the repulsion. I said to myself. Third, create another U-tape and place it on the 2 objects for support. Now this is the second part of the experiment. Fourth, and lastly, hold the first U-tape under the tape suspended by the objects and move it closer until tape starts to move upward. Now we're talking about tape B here. The materials required are 3 things. 1, a roll of tape. 2, a ruler. And 3, 2 objects placed on top of one another. But they need to be thick enough so they can stack. For the system, I said it was the 2 tapes, the top of the table, and the 2 objects used throughout the experiment. For the surroundings, it would be everything else in the environment. As you can see in my diagram, I have the electrical force pointing upward, and then the gravitational force pointing downwards. Now, in my own model, it is the same thing, but in drawing. And don't worry, I know how whimsical my drawing looks. It's beautiful. I assumed that both tapes have the same net charge, as seen in the diagram with the 2 obviously equally arrows. A bit skewed, but so what. And secondly, air resistance is not included in this. If it was, I would have drawn wind. Now for the data. Each length of my tape was 7 inches. Now, if we wanted to convert that to meters, it would be much smaller. Around 0.01778, because it is the same weight of the tape, but the weight of the tape is obviously converted to kilograms, which was 0.0001778. The distance was 0.03 between the 2 tapes, and the magnitude of the gravitational force of the floating tape was 0.0019342. Now we know that the net forces must equal one another for the electrical and gravitational, so we get the same value for the electrical force on the floating tape. The measured electrical charge, using our formulas previously, is computed to be 1.308 times 10 to the negative 8c. Now, this was my glow script. I couldn't upload the code because it wouldn't allow me to. But as you can see, we have our up yellow arrow being the electrical, our down arrow being the gravitational, our red circular dot is the A tape, and the blue dot would be point B of the blue tape. Now this is for the point charge. Let's continue for our line of charge computation. Now for this, I got the total number of electrons to be 8.6 times 10 to the 9. The total number of atoms using the formula of surface area divided by the area of an atom to be roughly 0.005 for the surface area divided by the area of an atom to be equal to 5 times 10 to the negative 17. And the ratio of atoms to electron is 1 to the 1.9433 times 10 to the negative 7. Now, for the glow script for the line charge, we can now see that it is spread out between the line rather than 2 select points, and you can see the code to the right. This is interesting because we did get different values compared to the 1 piece of tape for the single point compared to the line of charges. We got a much larger value for the 1 line of charges compared to the point. Now for the assumptions, I ignored air resistance, etc. Now, for the true versus computational, the electrical charges were not equal, and there was no true point charge in either model, so those were similar. And I may have made personal mistakes, such as error, and anything could have gone wrong computational wise due to the external environment I was in. I mean, I was in the middle of the hotel floor. So, if the roles were reversed for protons and electrons, it would be the exact same thing because those definitions don't define the true nature of each electron and proton. So if they did switch, it would be the same thing. Now, the point charge model and line charge model did give different values just because a singular point reduces the magnitude of the